Okay, so in this video we're going to have a look at the confidence interval for the mean. And we're going to have a look at that by looking at this example that I've got here. So we're going to take a particular town, and let's say, for example, that there are, let's say 10,000, there are 10,000 men in this particular town, 10,000 men. Now we want to know what the mean weight of the men in this particular town is. So we could go out and we could weigh every single man in the town and get the mean, and that would give us the mu. This would give us this value here, the mean of the population. This is the mean of the population. Now that's going to take a long time, and it could be expensive if you're employing someone to do this. So rather than measuring every single man in the town, we're going to take a sample, and our sample is going to be 300. We're going to randomly select 300 men from this particular town. And in this particular case, we find that the mean weight of this sample of 300 is 75 kilograms with a standard deviation of 20 kilograms. And what we want to do here is to construct a 95% confidence interval for the mean weight of the men in the town. So let's see what we're going to do here. We're going to have, first of all, look at what's called a point estimate. And the point we're going to the point estimate in this particular case is 75 kilograms. This is the mean weight of our sample, and from that we are going to make statements about the mean weight of the 10,000 men. Now, so this has got our point estimate. Now, what we want to do is, around this 75 kilograms, we want to conduct a 95% confidence interval. So how do we do that? Well, what we have to do is actually work out a margin of error. Margin of error. And this particular margin of error is called E. So how do we do that? Well, the formula for margin of error is going to be plus or minus 1.96 standard deviations from the mean. So it's going to be 1.96 standard errors in this case, because we're talking about samples. The standard error is going to be sigma over root n. This is our standard deviation. So what do we have here? We have plus or minus 1.96 sigma here. We don't have the standard deviation for the 10,000 men. However, we do have a standard deviation for the sample that we took, and it was quite a big sample of 300. So it's perfectly okay to use 20 kilograms here as our standard deviation. So we'll put 20 over the square root of 300. So we want 1.96 times 20, and then we want to divide that by the square root of 300. So that will give us a value of 2.2632 to 4 decimal places. Okay, so this is plus or minus this amount here. So this is our margin of error. So this is our mean here. Our mean here is our x bar here was 75 kilograms. We had a standard deviation of our x bar was 20 kilograms, and our sample size n was 300. Okay, so this is our margin of error around this 75 kilograms. So let's just calculate that. Just move this up a little bit again. Now we want to say that our actual mean, the mean of the population then, is going to lie somewhere between our 75 kilograms minus 2.2632 and our 75 kilograms plus 2.2632. So this is our population mean, okay? Now, when we work that out, we get a range of, let's see, 72.74 to 2 decimal places up to 77.26. 77.26 kilograms. So what we're saying here is that the true population mean, if we took the 10,000 men, measure their means, measure their weights rather, calculate the mean of the 10,000 into all the entire population, measure the mean of the weights of the entire population, it will lie somewhere within this range here. Now, however, this is a 95% confidence interval. This is a 95% confidence interval. So what does that actually mean? Well, what that means is if we were to put those 300 men back into the population and take another sample randomly selected of 300 and got the mean of those weights and did it again and again and again, and say we did this 100 times, so we did this entire calculation 100 times, we would find that the true population mean would appear within the range of values that we calculate. It would work, or it would appear within that range 95 times. 95 times out of 100. Out of 100 times that we did this whole procedure. So if we carried out this procedure 100 times, we would find that the true population mean would appear within the ranges that we calculate 95 times out of the 100 times that we did this calculation. Okay, so that's the procedure for calculating the confidence intervals for the true population mean. Now, we did this, as I say, for a 95% confidence interval. So you can also do other confidence intervals. For example, you can do a 90% confidence interval. You can do a 99% confidence interval. It's just a change in the formula, slight change in the formula. It's a number of standard deviations from the mean that we're going to change. So for a 90% confidence interval, we would be looking at plus a margin of error of plus or minus 1.645 times sigma over root n. So instead of 1.96, which is what we had here, 1.96 for a 95% confidence interval, we've changed that to 1.645. This part of the formula remains the same. Now for a 99% confidence interval, we've been talking about a margin of error plus or minus 2.575. 2.575 times sigma over root n. Now, if I carry out these calculations for in this particular example here, what kind of values would I get? Well, let's take 90%. What was the next one? 95% and 99%. Now, the confidence interval for 90% works out at 93.10 up to, sorry, that's wrong, it's actually 73.10, of course, 73.10 up to 75.11 kilograms. 95% confidence interval we worked out here, that was 72.74 up to 77.26. For a 99% confidence interval, we get 72.03 up as far as 77.97. So these are three sets of intervals that I've calculated. I've done the 95% one up here. These other ones I did separately. Now, if you look at these three sets of confidence intervals, what's happening to the range of values? Well, 90% is the smallest range, 95% is slightly bigger range, and 99% is the largest range here. And that would make sense in that if you are less confident about where the true population mean is, you would have a narrow range of values here. If you're 99% confident, if you're very, very confident, most confident in this particular case as to where the mean would lie, you would have a wider range of values here. So the higher the confidence interval, the wider the range of values inside which you would expect the population mean to lie.